So another example 3 now. A condenser of a capacity C farads. This is the capacitance C farads with B naught is discharged through a resistance R ohms. So that if Q coulomb is the charge on the condenser I ampere, the current and B the voltage at time t. Okay, we must know Q equals to CB and B is the equals to RI, where I equals to rate of change of charge with respect to time, that means dq by dt. Hence show that B equals to this. Now voltage across resistance Ri, R equals to what? Ri. Voltage drop across the capacitance Q by C. This is the actually formula for electric circuit, and this is the resistance R, this is the V naught, and this is the key, and this is the capacitor C. The equation of discharge of condenser can be written when after release the key, the condenser gets discharged and at the time voltage across the battery gets 0, so that B naught equals to what? 0. The differential equation of the above circuit can be written as Ri plus Q divided by C equals to 0, because voltage drop will be 0. From this we can write I equals to what? Dq dt plus Q by C equals to 0, as I equals to what? Dq dt. So from this differential equation we can write this one after dividing R on both sides. Then dq dt equals to minus this, minus dq. So by variable separable method we can write dq divided by q equals to minus 1 by RC dt. So here we have to integrate with respect to q, and here we have in right hand side we will integrate with respect to time. So after integrating on both sides, okay, we get 1 by x formula log x log q here with respect to q. So here only time t and plus a, this is the integral constants. But at time t equals to 0, the charge at the condenser is q naught. It is given. Okay, initial charge, number of charge will be q naught. So log q naught equals to minus 1 by RC into 0 plus a equals to what? Log q naught. So putting the values of integral constant a in equation 2, we can write log q equals to what? Minus 1 by RCT log q2. Just putting this value a here. So taking log in one side, left hand side, log q divided by q naught equals to this one, and q divided by q naught equals to e to the power this. Okay, removing log we can write e to the power this. Okay, this whole will be power on e. So q equals to q naught e to the power this. Now dividing both sides by 3, dividing both sides of 3 by q by c, sorry, by c, we get q by c equals to this. But q by c equals to what? B. So this is the actually law we have to derive. B equals to b naught, this one. Understand? And q equal to cb, using this b equals to ri also. So we have proved the condition. Now another example for circuits. The equation of electromotive force EMF in terms of current I for an electrical circuit having resistance R and a condenser of capacity C in series connection. This is the EMF, and electricity are going here on, and this is the capacitor, and this is the resistance R then going. So the equation equals to Ri plus integration over I by C dt. Find the current I at the time t when equals to this. So we have Ri plus integration I by C dt equals to in E. E means what? E naught sine omega t. Okay. So differentiating both sides, we can write dr di dt plus integration sign will be cancelled due to differentiation, and this differentiation what? Sign differentiation what? Cos, and multiplying with the coefficient of t. Coefficient of t what? Omega. So di by dt plus I by divided by RC equals to E naught divided by R, dividing by R on both sides. So integrating factor will be what? Coefficient of dependent variable. Understand? This is the linear differential equation of first order. So integrating factor will be what? E to the power p dt. P means what? P will be the coefficient of dependent variable I. Coefficient of I. Coefficient of I what? 1 by RC. 1 by RC is the P. And with respect to independent variable T. So e to the power T by RC integration. Now solution will be what? Dependent variable into integrating factor equal to integration of right hand side into integrating factor. Same words as previous lectures. So this will given by this integration. This is the integral constant A. Now using same formula, e to the power x cos bx. Understand? This is in previous example this was sine. So e to the power, this formula will be e to the power x divided by x square plus b square a cos bx plus b sin bx. Okay, using same formula we get this one. A means what here? A means e to the power, A means t 1 by RC. Okay, A means what? 1 by RC and B means omega. Okay, using this one we get this. This is the A is the integral constant. After simplifying this we get this one. R square C square is the LCM here. So we get this one. Then after calculation we can write this one. After dividing by e to the power t by RC. Okay, dividing by e to the power t by RC, this will be cancelled after division, and a into e to the power minus t by RC. So I equals to can be written as this is the actually required solution for the given differential equations. Now second order application of second order differential equations. We have already discussed about RL and RLC electric circuits. Okay, these two types circuits we have discussed in our previous example. Here we want to do circuit problem involving second order differential equation. Okay, the damped LRC circuits is governed by the equation L d square q dt square plus R dq by dt plus 1 by capital C into q equals to 0. This is the second order differential equations because highest differential coefficient is what? 2 times. There are second derivatives coefficient. So this is second order differential equations. And q is the dependent variable here and t is the independent variable. Remember it. Q, amount of charge. So where L, R, C are positive constants. These are L, R, C are positive constants. Find the condition under which the circuit is overdamped. We have to find out the conditions. Overdamped, underdamped, and critically damped. Three types of damped here. Find also the critical resistance. We have to find out the critical resistance. Very important example for you. Now given equation is, this is the actually given equations and this is the actually L d square q by dt square plus R dq by dt plus 1 by c q equals to 0. And this can be written as here actually right hand side 0. Okay, so this after dividing by L on both sides we can write R by L and this is will be 1 by LC equals to 0. This is equation number 1. Here actually coefficient R by L equals to what? We have taken some parameters for this. R by L equals to 2p and 1 by LC equals to what? Omega square. Understand? We have taken, we have considered this constants R by L, this ratio equals to 2p and 1 by LC equals to what? Omega square. Thus the given equation becomes this equation 1 becomes d square q by dt square plus 2p dq by dt plus this will be omega square q equals to 0. So this is the actually we can solve by the differential equation with constant coefficient method. This is the second order differential equation. And now we'll try to solve this by what? Constant coefficient method. So the auxiliary equation can be written as if equal e to the power y equals to e to the power mt be the trial solution, then auxiliary equation will be what? M square plus 2pm plus omega square equal to 0. Here, here will be what? Complex roots, right? This is the quadratic in M. Look like what? X square plus bx plus c equals to 0. If x square plus bx plus c equals to 0, then x equals to what will be? Minus b plus minus square root over b square minus 4ac divided by twice a. Using the same quadratic equation, we can solve this for m. So m equals to minus p plus minus square root p square minus omega square. Actually, square root over p square minus omega square. This is the actually what? Depending on p square minus omega square, there are different cases arise, because this is the actually complex roots. Understand? M. So depending on p square omega square, we are taking some cases here. When p is greater than omega, if p is the positive, if p is the uh, p is positive and also greater than omega, then roots are real and distinct solutions for the equation of 1. That means if p is greater than omega, then we can tell that the roots will be what? Real and distinct. This is the discriminant actually. B square minus 4ac types. Okay. This look like what? B square minus 4ac. Understand? In quadratic, what was? B square minus 4ac. Discriminant. This is called what? Discriminant. If discriminant is positive, then roots are what? Real and distinct roots. Understand? So if p greater than omega, then means discriminant is greater than 0. Discriminant is positive. Then the roots of this m, that means the value of m, will be real and distinct solution of equation 1. So q equals to what will be? A into e to the power mx, here t, mt, independent variable t, and plus b into e to the power mt. Understand? One is positive one and another was negative one. So in this case, q is always positive. This is the condition of over damping. If q is greater than, that means discriminant is greater than 0. Discriminant is positive, then it will be what? Over damping. So thus, if p is greater than omega, then r by lc greater than 1 by root over lc. Understand? P equals to what was? R by L. Okay. P equals to what? R by twice L. Understand? Because r by L equals to 2p. So p equals to what? R by twice L. And omega equals to what? 1 by root over LC. Understand? Omega equals to what? 1 by root over LC. So r by 12 p greater than omega means what? R by twice L greater than 1 by root over LC. So r greater than, multiplying twice L on both sides, we get 2 divided by root over L by C. Understand? This is the condition. If resistance greater than this values, then the condition will be what? Over damping. Understand? If resistance greater than this, then will be what? Over damping. Now another case, if p is less than omega, that means discriminant is negative. B square minus 4ac less than b square minus 4ac, this one. Discriminant p square minus omega square. So if p is less than omega, then roots will be what? Imaginary. Understand? Roots will be what? Imaginary. Then in that case, solution will be what? Solution e to the power minus pt a into cos root over this one plus b into sine root over this one. We must know about this, how to write the for solution, how to write the solution in constant coefficient if the roots are complex, because p less than omega means what? Roots are complex form, that means imaginary. Roots are imaginary. So we must know from our previous lecture how to write the complex roots. How to write the solution in that case? E to the power minus px pt a into cos root over this one plus b into sine root over this. Okay. So this is the period of oscillation decreases and this condition is of under damping. Understand? This is called another case for imaginary roots. Now for equal roots, if p equals to omega, that means if discriminant equals to 0. Understand? Then roots are equal. Understand? Roots are equal. In that case, we can write the solution for equal roots. Q equals to a plus bt e to the power minus pt. Understand? For equal roots, we can write one. If p equal to omega, this will be 0. Discriminant will be what? 0. This will become p square minus omega square will be 0 root. That means this will be 0. P square equal to omega square. This is why this whole will be 0. So m equals to only minus p. That means equal roots. So for p equals to omega, we can write the solution a plus bt e to the power minus pt. So there are three cases for equal roots, for imaginary roots, for real roots. Understand? For real, that means distinct roots. For distinct roots, for imaginary roots, and for equal roots, you must know about the how to write the solutions of the differential equation of constant coefficient. In constant coefficient method, we must know about these three cases. So if p equals to omega, p equals to what? R by 2s L, and omega equals to what? 1 by root over LC. So R equals to 2 into root over L by C. So for this case, last one, critically damping. For critically damping, resistance will be equals to this. Very easy for you, but very important example. Actually, under damped, over damped, and critically damped. This is the actually figure. And under damped damping factor, that means epsilon equals to 0. This is the under damped. Mm. Okay, another example. A circuit consists of resistance 5 ohms, inductance L 0.05 henries, and capacitance capital C 4 into 10 to the power minus 4 farads. If Q, initial conditions, two initial conditions are given, Q0 equals to 0, I0 equals to 0. Initial conditions. Find Qt and It when an EMF of 110 volts is applied. This is the actually a part of application of differential equation in electric circuits. This is the actually circuit problem. Okay, for these types of circuit, L equals to electric inductance, C capacitor, R resistance, and this is the EMF. E equals to 110 volts. 110 volts. So electricity is passing through here. Then the circuit problem differential equation will be this: L equals to d square q by dt square plus R dq by dt plus 1 by C q equals to 110. Understand? This is the equation number 1. Dividing by L on both sides, we get this. Similar process. We will proceed on similar process. R by L equals to what? Twice P. And 1 by LC equals to what? Omega square. Okay? 1 by LC. Here Q is capital Q is the amount of charge, total amount of charge. Capital Q will be the dependent variable and T is the independent variable. Remember it. So the equation becomes linear differential equations. Okay, with what? 220, 200, because L equals to 0.05. This is the given. So this is the auxiliary equation. Auxiliary equation what will be? M square plus 2pm plus omega square equal to 0. If e to the power mt be the trial solution of this given differential equation. Then the auxiliary equation will be what? M square plus 2pm plus omega square equal to 0. So this is the quadratic equation. After solving, we get what? M equals to minus p plus minus square root p square minus omega square. Just before result, previous result. In previous example, we got this result also. So here R equals to 5 ohm, L equals to what? 0.05 henries, and capital C equals to what? These farads. So 2p equals to what will be? R by L equals to 100 and p equals to what? 50. Omega square equal to 1 by LC. Putting the values, we get what? 50,000. Omega square equal to 50,000. So putting the values of p omega in this one, the roots will be m equals to what will be this? M equals to plus minus this one into I. Okay, we get m equals to this one. I is the imaginary number here. Remember it, not electricity. Understand? I is not electricity. I will be the what? Imaginary number. So complementary function can be written as, for this imaginary roots, complementary function will be what? E to the power minus 50t a into cos this one, cos this t plus b sine 50 root over 19t. Understand? For complementary function, we get this for these two imaginary roots. Now particular integral what will be? We must know from our previous lecture.
সময় ব্যথা পাবে
Particular integral will be 1 divided by right hand side, that means left hand side coefficient of dependent variable, this one. Okay, dividing with this capital D square. Capital D means what? Dq dt. So 2pd plus omega square, this is the right hand side, 2200. So 1 by d square plus 100d plus 50,000. Capital D equals to what? Capital D equals to 0. Why capital D 0? Here putting the value of p equal to 50, we get, and omega square equal to 50,000, we get this. Here in this you can write e to the power 0 into t. Understand? E to the power 0 into t you can write. Okay, e to the power 0 into t. Understand? E to the power 0 into e to the power 0 into t na. E to the power 0 into t means what? 1. So in exponential form, t coefficient what? 0. This is why putting d equals to 0 here. Understand? We get particular integral equals to 11 divided by 250. With this, we have applied what? Multiply e to the power 0 into t. So for e to the power ma, e to the power x, putting the coefficient of t in replace of d. We must know about these rules for exponential function, how to find out the particular integral. Okay, in our previous lecture, constant coefficient method for ordinary differential equation, we must know about this method. E to the power x, if there are exponential function, then we can put the uh, coefficient of independent variable in replace of d. So there e to the power 0 into t you can write. So 0 is the coefficient of t, so replacing d equals to 0. So particular integral 11 by 250. So complete solution, general solution, complementary function plus particular integral, that means q equals to this one. Now on putting q equals to 0, t equals to 0 in equation 4, we get, we have to find out these two constants a and b. Okay, so on putting, if there is no charge transfer, q equals to 0 at time t equals 0, this is the initial condition. Initial condition, q equals to 0, q equals to t equals to 0. When t equals to 0, q equals to 0. When t equals to 0, I equals to 0. Remember it. This is our given initial condition. So if q equals to 0, then t equals to 0. So q equals to what will be from equation 4? Q equals to e to the power 0 means what? 1. The a into cos 0 means what? 1. And sin 0 equals to 0. So a plus this one. Okay, a plus 11 by 250. After putting q equals to 0 and t equals to 0, we got q equals to a plus 11 by 250. So a equals to what was? If q equals to 0, then only a equals to 11 minus 11 by 250. So on differentiating 4, if we differentiate, I equals to what? Dq by dt. Rate of change of charge with respect to time will give electricity. So I equals to dq by dt. If we differentiate this equation 4, dq dt with respect to t, we get minus 50. E to the power x formula what? E to the power x multiplying with the coefficient of t. Here t is the independent variable. So a cos this one, a cos this one plus b sine this one. Okay, that means ub formula, u into differentiation of b plus b into differentiation of u. We are applying this. So b into differentiation of u. Cos differentiation what? Minus sign. Okay, so minus sign multiplying with the coefficient of t. Coefficient of t what? 50 root over 19. So multiplying with this. Again, b is the constant and sine formula what? Differentiation cos. Again multiplying with the coefficient of t, 50 root over 19. So using ub formula, u into b plus b into u. Okay, so using the, we get the equation number 5. Now on putting I equals to 0, t equals to 0 in equation 5, because this is our previous condition, given initial condition. Okay, so if I equals to 0, then t equals to what will be? 0. I equals to 0 means, and putting t equals to 0 in whole equation. This is the a big equation 5. So putting t equals to 0, e to the power 0 means what? 1. E to the power 0 means 1. So minus 50. And a equals to what? Minus 11 by 250 given. Okay. So cos 0 what? Cos 0 1. So b sin 0 means whole 0 plus e to the power 0 means what? 1. So minus 50 and sin 0 what? This will be whole 0. So only this one 50 root over 19 into b, and cos 0 what? 1. Okay. So we get this one from equation 5 after putting I equals to 0 and t equals to 0. So b equals to what will be? B equals to this one equals to here, b equals to 11 by 5 into 50 root over 19. Okay, so b equals to can be written as 550 means what? 250 root over 19. So on putting the values of a and b, we got the values of a equals to 11 by minus 11 by 250 and b equals to minus 11 by 250 root over 19. So putting these values in equation number 4, which was the complete solution. Okay, and this will give the whole complete solution. Q equals to this. Just putting a and b values in equation 4. So on putting the values of a and b in equation 5, we get I equals to what will be? In 5, putting the values of a and b. Okay, a and b, we get a huge equation, big equation. So just taking common e to the power minus 50t, e to the power minus 50t, and cos common, sine common from here. Okay, we get this one. So I equals to can be written as e to the power minus 50t. After simplifying this, then we get this one. 11 by 5, 11 by 5 will be cancelled, 0. So 0 into cos something 0. Okay, so taking LCM, 5 root over 19, we get this one. So I equals to this one t, and this can be written as 44 divided by root over 19 e to the power minus 50t sine 50 root over 19t. Okay, this is the result. And we have to find out the values of I and values of Q. Q will give equation 4 and I will give equation number 5. So this is the result. Qt and It. Okay. Okay, an electric circuit consists of an inductance 0.1 Henry, resistance of 20 ohm, a condenser of a capacitance 25 microfarads. Find a charge Q and current I at time t given the initial conditions Q equals to this coulombs, I equals to 0 when t equals to 0. Okay, when t equals to 0, Q equals to this and I equals to 0. The differential equation of the above circuit given condition using the circuit L, R, C. The differential equations can be written as L di dt plus Ri plus Q by C equals to 0. Okay, so dividing by L on both sides, we get this one. So I equals to what? Dq dt. Remember it. So this is the actually linear differential equation. So R by L equals to what? R by L, putting R by L equals to 2B and B equals to what will be R by 12. Taking substitution, R by L equals to what? 2B. So B equals to R by 2SL. So you get 100 and 1 by LC equals to K square. You can take omega square also. And you can take, but here K square, same words. So K equals to what was? What is 1 by root over 1 by LC. Putting the values, L equals to this one, S equals to this microfarad. Okay, this one 10 to the power minus 6. Micro means what? 10 to the power minus 6. Remember it. So we get the value, this is greater than 100. So our equation reduces to, this is the d square q by dt square 2b and k square q. So auxiliary equation will be in this case m square plus 2bm plus k square equal to 0. So that m equals to what? Solving. This is quadratic in m. So m equals to minus b plus minus square root b square minus 4ac divided by twice a formula. So we get these two constants. Now here minus b plus minus z root over k square minus b square. That means taking k in first and b square in last. So there is minus 1. So minus 1 means what? I square. But we have taken z here in place of I, imaginary number. So complementary function will be q equals to what will be? E to the power minus bt a cos root over this t plus b sine root over this t. Okay. On putting q equals to 0.05, putting q equals to 0.05 at time t equals to 0, we get from this equation 1 dq dt equals to what will be? We get a equals to, putting t equals to 0, this will be 0 whole. Okay, and putting this equals to t equals to 0, this will be only a, and e to the power 0. So q equals to what? A. Understand? Q equals to capital A. But q equals to what was? 0.05. Q charge 0.05. So on differentiating 1, if we differentiate equation 1, then dq dt means what? I, electricity. Okay, to get electricity I, we are differentiating this one on both sides with respect to t. So dq dt equals to ub formula. We have to apply ub formula as previous example. So u means what? Third bracket, whole third bracket, considering u into integrate differentiation of b, e to the power minus bt formula, e to the power minus bt, but uh, multiplying with the coefficient of t minus b. Okay, minus b, this is the u, and plus b into this is b, and u differentiation, this differentiation what? A cos differentiation what? Minus sign. Understand? And multiplying with the coefficient of what? T. Coefficient of t what? Root over k square minus b square plus b into sine formula what? Cos. Again multiplying with the coefficient of t, b into root over k square minus b square. Understand? So on putting dq dt equals to 0, because I equals to 0. I equals to 0 is given condition. Okay, I equals to 0 at time t equals to 0. So dq dt means what? I. Understand? The dq dt equals to what will be 0 and t equals to 0. Putting in equation 2, t equals to 0, and dq by dt equals to 0, Then e to the power 0 means what? Only minus b. Cos 0 means what? 1. So only a. And b into sin 0 means what? Whole 0. E to the power 0 means 1. So this whole sin 0 means what? 0, whole 0. And b into this one exists. B into this one, cos 0 means what? 1. This is why we get a plus. So from here, b equals to what will be? Small b, capital A divided by square root over this. Putting the values of a, capital A, we get this one. Okay, capital A equals to what was? 0.05 putting. So b equals to, we get this result. Now substituting the values of a and b in equation 1, we get q equals to this. Equation number 3. Now from here, square root over k square minus b square equal to what? Putting the value of k and b. Okay, we get 624.5. So on putting these values in equation 3, this values equals to 624, just we get this result. Okay, and on differentiating dq by dt, differentiating this equation, we get electricity. Okay, using same what? Same formula, uv process. U into this whole u into b differentiation. This differentiation what? E to the power x formula, e to the power x, multiplying with the coefficient of t minus 100. Okay, so u into b differentiation plus b into u differentiation. Just we get this approximately result. And this cos will be cancelled. Okay, this cos and this cos will be cancelled. This is why this sign will be exist. And this is the result. Now another example, an alternating EMF. EMF is E sin omega t is applied to an inductance L, capacitance C in series. Show that the current in the electric circuit is this. Okay, where N square equal to 1 by LC. Now differential equation for the above circuit, we can write, this is the actually circuit. L d square q by dt square plus q by c equals to E. E means what? EMF. So dividing by L on, we get this one. So this can be written as by what? Coefficients method. Constant coefficients method. We can write dq dt equals to capital D, this one. So auxiliary equation will be left hand side equals to 0. So m square plus 1 by LC equals to 0. Actually, if y equals to e to the power m t is the trial solution, then you can write this auxiliary equation. Okay, so m square plus n square, n means what? 1 by LC. This is also given, n square. So m equals to what? Plus minus n, two roots. Complementary function will be a cos n t plus b sin n t. Okay, particular integral what will be 1 divided by left hand side into right hand side. Okay, so particular integral will be for sine function. The d square can be substituted by what? Minus a square. That means minus omega square. Okay, d square equals to what will be? Minus omega square for sine or cos function. So complete solution will be q equals to complementary function plus particular integral. This is the actually result. Okay, now putting q equals to 0 at time t equals to 0. This is the initial condition. If q equals to 0 and t equals to 0, this will be 1 and a plus this 0 and this also 0. So 0 equals to a. So a equals to what is 0. So on putting the value of a in equation 1, we can write this one. Now differentiating dq by dt to find out I. Okay, differentiating sine differentiation cos, multiplying with the coefficient of what? T, bn. So and this is the whole constant, and sine differentiation what? Cos, multiplying with the coefficient of t, omega. So imposing another initial condition, I equals to 0 when t equals to 0. We get I equals to 0, t equals to 0, cos 0 means what? Only bn, and cos 0 means only this constant. Cos 0 equals to what? 1. This is why. So this from here b equals to only this constant. Now putting the value of b in equation 3, okay, we get this result. Now taking common, we get this one. Actually, these equations we have proved. Okay, this is the current, electric current in the circuit. Very easy. Now another example, for an electric circuit with a circuit constant LRC, Q is a plate condenser is given by this differential equation, current this, and L equals to 1 Henry, C equals to this farad, 10 to the minus 4 farad, R equals to 100 ohm, E equals to 100 volts. Then suppose there will be no charge present and no current at flow at time t equals to 0. That means Q equals to 0 and I equals to 0 when t equals to 0. Okay. So when EMF is applied, determine Q and I at time any time. Actually this solution will be as the previous example we have studied. The differential equation this dividing with by L on both sides, R by L equals to twice B, 1 by L is equal to K square. Then this is the linear differential equation. Now applying the linear differential equation constant coefficient method, we get Q equals to what? This one, particular integral. This is the particular complementary function, and this is the complementary function. This is the particular integral. Okay, particular integral. Remember it. There is no solution because we have solved these types of equation. We have solved higher actually in our previous example. This one. Okay, this one. This solution I have written, this solution. Okay, this solution written. Understand? This complementary function. I have written this complementary function. And particular integral will be very easy for you. So we have written this solution Q. Now putting Q equals to 0 at time t equals to 0, we get this one A equals to what? Minus E by K square L. Now differentiating this to get I, okay, UV method. Okay, UV method, we get equation number 3. So dq dt equals to what? I equals to 0 at time t equals to 0. Now putting t equals to 0 here, and dq dt will be 0 for that. So we get this one because sin 0 equals to 0, and this cos 0 means 1, just constant will be exist, and this constant will be exist. So I have minus b e to the power 0 means 1 minus b a cos this equals to 0, cos something is cos 0 what? 1. So minus ba plus b into this. B equals to what will be? This one. A equals to putting the value of a from here, we get this one. So b is total b's value will be this. Now substituting the value of ab in equation number 2 in the solution, we get this whole one, and this is the q. From this taking common e by k square l, e divided by k square l, we get this one, equation number 4. Now here e divided by k square l equals to, just putting the values given, e divided by k means what? 1 by lc into l. That means ll cut and only ec means what? 1 by 100, and b equals to r by twice l. This also values given, so 50, b equals to 50. So k square minus b square, this is the angle. K square minus b square will be values what? 50 root 3. Now putting the values, q equals to will be this. This is the result. Mechanical engineering problem means actually we robotics problem also, to study the movement of a robot. uh, Also mechanical engineering problem. Actually you must know about this. Velocity equals to what? B equals to dx by dt, and acceleration can be written as d square x by dt square. Okay, rate of change of non-uniform velocity will give acceleration. So acceleration can be written as b dv by dx also. F equals to ma, from this also f equals to mb dv by dx. This is also differential equation because differential coefficient present in the formula of force. Now we'll try to study the example 11. A moving body is opposed by a force per unit mass of value cx and resistance per unit mass of value b square. where x and b are the displacement. X is the displacement and b is the velocity of the particle at time at that instant. Okay, find the velocity of the particle in terms of x if it starts from rest. That means starting with rest, distance 0. The Newton's second law of motion, we can write b f equals to ma from second law, b db dt equals to minus cx minus bb square. Okay, this is the complete differential equation of first order. So here b square equals to, taking b square equals to what, z. So we can substitute dz by dx here. So the complete dz by dx, db dx, what will be 1/2 dz by dx plus bz minus cx. That means this becomes a linear differential equation of first order. Understand? Here z is the dependent variable and x is the independent variable. So integrating factor will be what? E to the power integration of coefficient of dependent variable. That means what? Twice b dt dx. Integrating with respect to x, we get 2bx. Now the solution will be what? Dependent variable into integrating factor equal to integration of right hand side into integrating factor. This a is the, capital I is the integral constant. Now e to the power ub process here. X is the u and e to the power 2 twice bx is b. The ub process integration u into integration of b minus differentiation of u integration of b. Okay, again the whole integration. So this integration will be e to the power x formula, e to the power x dividing with the coefficient of x. This means dividing with the coefficient of x. X means what? Coefficient of x, coefficient be what? Twice b. Okay, so we get this one. This is the dash is the actually integral constant. So z equals to, dividing with this, e to the power 2 bx on both sides. Z equals to, we get this one. This will be cancelled. This will be cancelled due to the division. Okay, capital A dash divided by e to the power minus twice bx. So z equals to what was? B square. We have substituted b square equals to z. This is why z equals to b square. This one. Now putting b equals to 0, velocity was 0 when it was rest. Starting from rest, velocity what was? 0. So we get 0. Putting b equals to 0 and x equals to 0, we get a dash equals to what? Minus c divided by b square. So equation 2 becomes very easy for you. Just putting the values of a dash. Now another mechanical engineering application. A particle of mass m moves on in a straight line under the action of force mn square x. This is the force mn square x, which is always directed towards a fixed point O on line. Determine the displacement xt if the resistance to the motion is this. This is the resistance of air. That is, initially x equals to 0 and velocity will be 0 and lambda lies between 0 and 1. That means lambda always positive, non-negative. So by equation of motion of second law of motion, F equal to rate of change of momentum. This is the force and this is also resistance of air. Okay, so using this dB dx equals to, we can write this where b equals to, taking b equals to zx. This is the actually homogeneous linear differential equation. So taking b equals to zx, we get this one. This is the linear one. Okay, now putting the value of b and dB dx in equation 1, we get this whole xz dz by dx, just this one. Okay, now integrating on both sides by variable separable method, we get this one. From this, dx divided by 1 by x and this divided by dz, dz divided by this one. Okay, z divided by this one. Separating the variables and then integrating on both sides, we get z dz, z equals to what? 2n lambda minus 2n lambda. This is actually cancelled. So twice half, taking half, we have taken what? Twice z. then plus twice n lambda minus twice n lambda. To integrate this 2z plus twice n lambda divided by this whole minus separating this divided by this one. Okay, then right hand side. So the differentiation of denominator, we get the numerator. Okay, the differentiation of denominator, we get the numerator. So the result of this integration will be log this, log 1 log denominator minus lambda n lambda n divided by z square minus 2 lambda n z plus lambda square n square plus n square minus lambda square n square. This cancelled. Okay, just we have taken this to make this a plus b whole square formula. Okay, to to take this integration minus 1 by x formula log x. Okay, minus log x plus c. So half log this is the same minus lambda n integration of, we have to taken this x square minus x square plus a square. A means what? N 1 minus lambda root over 1 minus lambda square whole square. Okay, this is the formula of what? 1 divided by x square plus a square. X square plus a square formula what? 1 by a tan inverse x by a formula. Okay, 1 by a means what? This whole. A means what? This whole within third bracket. 1 by a tan inverse x. X means what? Z plus lambda n. Z plus lambda n is the x. So formula will be 1 by x square plus a square. Integration of 1 by x square plus a square will be 1 by a tan inverse x divided by a. This log will be here. So this is only c. Now this one log, taking log in a body, a log x into this minus n cancel lambda divided by this tan inverse this. So z equals to what? B by x, because z equals to bx. This is why z equals to what was? B equals to what was? Zx. Z equals to what will be? B divided by x. So putting z equals to b divided by x and z equals to b divided by x, we get this one. Z equals to what will be? B divided by x. So log this one, taking x square LCM, we get this one, and xx will be cancelled, minus lambda divided by root over 1 minus lambda square tan inverse, we get this one, taking LCM in numerator, we get this, and n will be nx multiply root over 1 minus lambda square. Now putting b equals to 0 when it start from rest, that means x equals to 0. When it started from rest, velocity what was? 0. This is why putting b equals to 0 and x equals to 0 in this equation 2. So log 0, this will be whole 0, x equals to 0, x equals to 0, velocity 0. Okay, whole 0 and lambda divided by root over 1 minus lambda square equal to 0. That means c equals to what? Z 0. So putting c equals to 0 in equation 2, you get this is the solution of this motion. Okay, of particle. Understand everybody? A body falling vertically under gravity encounter resistance of the atmosphere. If the resistance varies as the velocity, show that the equation of the motion is given by this. Here u is the velocity and k is the constant and z is the acceleration due to gravity. Show that as t increases, u approaches the value z divided by k. Also, if u equals to this, that means velocity, where x is the distance fallen by the body from the rest at time t, show that x equal to be this one. We have to show two conditions. One is for velocity, initial velocity, and this is for distance, displacement. Let the mass of the falling body be unity. Okay, acceleration will be what? Du dt. Now force acting downwards, force ma, this is the acceleration. Okay, m is the unit body, unit mass. Okay, unit means what? 1. Understand? Unit mass, this is why 1 m, and m is what? Du dt. So force will be what? Du dt. Force resistance will be ku. This is given. Net force acting downward Z minus Q. Therefore, du dt equals to Z minus Ku. This is the actually proved condition. Now, from this differential, this is the first order differential equation. Du divided by Z minus Ku equals to dt. We can integrate by variable separable method. We get this is the integration, taking integration on both sides of this. We get t equals to what will be 1 by x formula, what? Log x. Understand? Dividing with the coefficient of u, because we are integrating with respect to u. Understand? 1 by x formula log x, but dividing with the coefficient of u, 1 by k, 1 by minus k. Okay, and log a is the constant, integral constant. Now taking uh, log this one into a. Okay, minus 1 by k will be power after log something. Okay, this can be taken as power. This is why minus 1 by k power. Now taking exponential function on both sides, exponential form on both sides, into z minus ku to the power minus 1 by k equals to e to the power t. So this equals to taking power k on both sides, taking power k on both sides. So it will give a to the power k, and this to the power k means what? K cancelled. Understand? And this is will be what? E to the power kt. Now taking inverse on both sides. Okay, we get a to the this equals to a to the power k e to the power minus kt. So u equal to what will be? U equal to, from this, z divided by k, dividing by k on both sides, minus a to the power k e to the power kt. If t increases very large, that means if t tends to 0, sorry, t tends to infinity. Understand? If t tends to infinity, then this will becomes what? E to the power a to the power k divided by k e to the power kt equals to 0, because e to the power minus infinity means what? 1 by e to the power infinity. 1 by e to the power infinity, e to the power infinity means what? Infinity. So 1 by infinity equal to 0. This is why whole becomes 0 for t increases. Now from this, u equals to what? U equals to what? This one, this whole 0 becomes 0 after t increases. So equals to 0 divided by k when t tends to infinity. So u equals to what? Dx by dt, you must know. And du dt equals to what? Acceleration, d square x by dt square. So putting this du dt in and u in equation 1, we get this differential equation. Understand? From equation 1, u means what? U means dx by dt, and du dt means what? D square x by dt square. Putting this in equation 1, we get this differential equation, and this can be written as capital D square plus kdx equals to z. We can solve this by constant coefficient method. Here capital D equals to what? Dt dx, that means dx by dt. Okay, now auxiliary equation will be, if e to the power mx be the trial solution, then auxiliary equation what will be? M square plus k mk equals to 0. Left hand side equals to 0 will give auxiliary equation. So solving this, we get two distinct roots, m equals to 0 and m equals to minus k. So complementary function will be what? First constant e to the power 0x, that means 1. Second constant e to the power minus k t. T is the dependent variable here. T is the independent variable and x is the dependent variable here. Remember it. Dx square x by dt square. This is why. Here x is the dependent variable and t is the independent variable. This is why the complementary function is this types. Now particular integral what will be? 1 divided by left hand side. Left hand side means what? Coefficient of dependent variable x multiply right hand side. Right hand side z. So 1 divided by d square means uh, this is the right hand side z, and 1 by d capital D square plus kd equals to can be written as t1 divided by 2d plus k into z. How? Actually, e to the if we take e to the power 0 into t, then putting d equals to 0 will be undefined. Understand? So we have to take differentiation, multiplying with the independent variable. Multiplying an independent variable, that means t can differentiate this. Okay, 2d plus k. Now we get t divided by k, taking k common from here, taking k common. After taking common k, we get what? 1 plus 2d by k. This can be written as 1 plus x to the power minus 1. 1 plus x to the power minus 1 formula what? 1 plus 1 minus x plus x square. X square means this square plus x cube plus minus x4 in this way. Okay. So only two term will be exist because there are single g. Now multiplying z with 1, we get only tz by k, but differentiation of z what? 0. Z is the constant 9.8. So differentiation with respect to t will be 0. This is why this result will be only tc by k. So complete solution, uh, complementary function plus particular integral. This is the particular integral. Okay. Now this is the complete solution. Now putting the values of t equals to 0 and x equals to 0 in equation 2, we get a1 plus a2 equals to what? 0. That means a2 equals to can be taken as minus a1. Now then equation 2 becomes x equals to a1 minus a1, putting a2 equals to minus a1. Okay, we get this. Now on differentiating with respect to t on both sides, we get the velocity dx by dt. Okay, equation number 4. So putting dx by dt, velocity will be 0 at time t equals to 0 because it started with rest, from rest. So we get a1 equals to this one. Putting the value of a1 in equation number 3, we get the complete solution. This is the actually particular solution. Okay. Similarly, example 14 will be homework for you. Similar process, and 14 example will be homework for you. Now for vertical elastic string and horizontal elastic string, um, there are example 16 will be homework for you. Same procedure, simple harmonic motion, important motion. Uh, there are another example. So example 17 will be homework for you. 18, example 18, 19. Okay, example 20, same procedure. Okay, example 20, then 21. Okay, 20 up to 21 will be homework for you.